So moving on, what do you think does it mean by saying keep track of? Like a lot of these paragraphs begin by saying keep track of. Well, it could be two things, right? One thing is essentially at runtime, you need to be aware of this and essentially recognize this process or event or user action. But the second meaning of it usually is also keep track of in terms of actually storing information in a database. So we basically have to be alert to both of these things. The register. So let's move on to the second phrase here. The register record of each cycle shall identify the register, the user, the dates and times to log on, and so forth. So very clearly, I think this, wherever it says record, right, it's likely the database record. So very likely we would like to recognize and keep track of register. Essentially, we can. Oftentimes just copy and paste whatever the user is, whatever their vocabulary is, right? So we can just say, okay, register record. Register record is one of the records that we want to be able to keep track of in the system, right? And of course, it has whatever notation you use at this point, but it will say register ID, most likely generated by the database, user, most likely the user ID, right? We can even say cashier ID, and then date, time, say timestamp. We can say log on timestamp, log off timestamp when they log off the system. And also the amount of sales, right? So the dollar amount of sales. So that we essentially recognize that, okay, for each register, there will be a table which will keep track of these entities or database records, which is, in our terminology, will be the same, and we're going to store this information. This information can change, improve, be modified, updated as we go through stages of this, but that's pretty much what I think about it right now. And essentially, this cash register object, which we will have in memory during these operations, is very likely that this cache register will simply be generating these records. At some point, it will try to connect to the persistence layer and tell it, I would like to create this record because right now I have completed this transaction. And so it will move on to that stage and essentially generate these records as we process sales. Now, notice that register record of each cycle, essentially, it tells me that perhaps the cycle itself is connected to the register, right? So that we may be able to recognize this at each register there is an active cycle of sales which is simply identified and connected to the actual cashier. By the way, I wouldn't hesitate to also add the cashier. Essentially, the cashier, what I'm spelling it wrong, right? The cashier as type of object in the system, because it can effectively store all the. And here I'm also spelling it wrong, right? Cashier ID. All right, so that it can store the information related to the cashier, cashier ID, cashier name, and other information that we may need to associate with the cashier. Number two, keep track of the drawer for each cashier on duty, right? So again, Sometimes you can basically in the system. Remember, we're having a system of abstractions, right? We're not really trying to emulate or simulate each little detail about the actual store operation, but rather an abstraction. So perhaps the drawer information could be associated with the cashier, and the drawer could be simply just basically just an attribute, one of the data attributes, such as drawer ID, which is stored at the cashier object, so that we know that this specific cashier has the specific drawer ID, right? Or the drawer could become a separate object. So I don't know yet, but it's very likely. Right now, I'm not willing to give the drawer a specific recognition as an object. However, the next thing that it says that the drawer keeps track of. And then I begin to think, well, you know what, look, it should keep track of total amount of sales made by the single cashier during the entire shift, all right? So I may also recognize shifts in the system. But at this point, maybe a drawer could become a separate class, separate object, which will keep track of all of this information. And then, instead of just using drawer ID somewhere inside the cashier class, I can have a reference from cashier to the drawer class, right? So this is not very obvious right now, but these are just some of the observations, and it doesn't have to be perfect as long as we're capturing the essence of the interaction in the system. So see how we're moving in the direction so that we recognize objects, we recognize use cases. By the way, do we have any combination here? Well, I guess we keep saying sale, so we can definitely say process sale as one of the use cases, prominent use cases in the system that will be obviously as well originated at a specific cash register. So this is a use case. Process sale is definitely a use case. Cashier can move during the shift with the same drawer between the registers if reassigned by a manager, right? So number one, the cashier is definitely an actor in the system, right? So you see, internally we can represent an actor by a business object such as cashier, but at the same time we should recognize the cashier as basically a person with an authority to process sales and do things like log on, log off, and so forth. So it's clearly an actor, and we also have this manager. Right, so we also have this manager. We can say store manager, right? Store manager, which is another actor which can do things to the system, and we may or may not need to have also a software class or object which directly supports the manager's set of data attributes, right? So, but at this point, as long as I have it someplace, I'm not overly concerned. My list of objects doesn't have to be absolutely perfect and complete. I'm still in the process of making decisions about what would be best representation in software of these things. All right, so assign, reassign is pretty much the same thing. So assign, right? Assign cashier will be another use case, right? Which I think we need to be able to execute in the system. Cashiers will move during the shift between registers if reassigned by the manager. So clearly the manager is the actor who will be executing this assigned cashier use case. Since we begin to identify actors with use cases, then we can begin to essentially maybe draw some diagrams, and in UML, in Unified Modeling Language, which we will more formally introduce maybe like next week, but right now I will just very informally show you that this is what I already begin to picture, is that I have this actor, and this is what UML uses for pictogram to display the actor, right? So cashier. Okay, and so the cashier can log on, they can log off, right? They can process sale, right? So this is the set of use cases I already have, and so we also have a store manager actor like this, store manager, which is another actor in the system. And so what they can do is assign register, right? We can assign cashier, I guess, would be maybe to a register, right? So these are well distinct and well recognized types of using the system. So typically you hold them in a bubble like this, and they will be typically referred to as use cases, and you can even sort of like try filling them in with a certain color, right, so that we can recognize these little bubbles, right? And then we can say that this is our just change the color. Right, so this could be, generally speaking, our point of sale use case diagram. The users feel very comfortable about these types of diagrams. I think they're very, very effective, and essentially they're put us on this big view of the system. And again, just a couple of notes, basically technical notes about use case diagrams, that you would like to realize that there is this boundary right here that separates the actors from the system, right? So everything on this side is not part of our system. It's just basically someone acting and doing things to the system, and generally speaking can be viewed as dangerous entity because they can do harm. They can make mistakes, they can do malicious things, they can just basically try things that are normally not anticipated and so forth, right? So they're basically an outside entities and clearly outside of the system. And these bubbles essentially contribute to the set of functionality that the system recognizes and uses. Another interesting thing is that we can say, but wait a minute, the store manager could assign themselves to a specific register and start doing like log on, log off, and process sales and things like that. Right? So the store manager may be able to act in capacity of the cashier. With this in mind, typically it's not that you want to essentially do the same connections. You could direct these connections between this specific actor and this specific use cases. But UML allows you to do this, basically use generalization and say, well, store manager is a, like, let me just maybe do a little bit more careful. Is a, or can act in the capacity of the actual cashier. Okay, so you can just say basically this relationship that the store manager is also a cashier is that they can act in capacity of that specific actor, right? So, and look at the direction of some UML diagrams actually use like directional lines over here, but this is excessive and not necessary, right? Because we know that it's an actor doing things to the system, and they will be executing one specific use case at a time. in a typical scenario. But notice the direction of this arrow, right? So we say that, okay, this actor can also do all these things, right? So these directions are important because they tell us how to interpret the diagram. The good thing about there are two good things about use case diagrams. Don't mix them with functional specs. They're not functional specifications. In fact, use case diagram is not a use case per se description, because use case is actually a well-written story about someone using the system. But they are very effective top-level view of what the system can do versus who can do and who can execute these use cases. Okay, all right. All right, so more about use cases in the future, but it's just like it's very natural to think about these terms, and this gives any kind of effective diagram can be much more effective than just written text, which you have to basically read and memorize and reread and take notes about. So it's a little harder to work with. All right, so I'm just moving on with some of these ideas and things that I can recognize in the system, giving you a sample, sample type of interpretation. So again, so see how I can do some drawing, and I can also keep notes about actors, objects, entities, which are database persistent records, and also these use cases, which are also visible here. All right. Okay, so let's move on.